Very good day to all of you. In the JEE question discussion, we'll see the first question. The rear side of a truck is open and a box of 40 kg is placed 5 meters away from open end as shown. The coefficient of friction between the box and the surface below it is 0.15. On a straight road, the truck starts from rest and accelerates at 2 meters per second square. At what distance from the starting point does the box fall off the truck? That is distance traveled by the truck. So you need to find out what is the distance traveled by the truck if the truck is falling. If the box is falling from the truck at the time for the box is falling from the truck. So this is the truck and this is the box, which is at a distance of 5 meters away from the rear end. 5 meters away from the rear end, and when the truck is moving forward with an acceleration of 2 meters per second square, the box in it is experiencing an acceleration of 2 meters per second square in the backward direction. That is the pseudo acceleration experienced by the block. And the coefficient of friction between the surface of the block and the surface of the truck is mu equal to 0.15. Therefore, the acceleration produced by the frictional force is equal to mu k into g. You know that mu k is 0.15 into g is 10. So we'll be getting 1.5 is the acceleration produced by the friction that is in the forward direction. This acceleration will be in the forward direction. So what is the resultant acceleration? Net acceleration is equal to a minus af. That is equal to a value is 2 meters per second square, af is 1.5, so we'll be getting 0.5 meters per second square is the resultant acceleration of the box. So the distance traveled by the box to fall from the truck is 5 meters. So the displacement s is equal to half into a into t square. We'll take that s is 5 meters and 1 by 2 into net acceleration of the box is 1 by 2 again, 1 by 2 into t square. So we're getting t square is equal to 5 into 4, 20. This is a value for t. T is equal to root of 20 seconds. Now, for that time, what is the distance traveled by the truck is the question. So the distance traveled by the truck is equal to 1 by 2 into a into t square, because the truck is starting from rest. So initial velocity is equal to 0. St is equal to 1 by 2 into acceleration of the truck is 2 meters per second square. T square is 20. So the answer is 20 meters. The distance traveled by the truck is equal to 20 meters. Is it clear? Now question number 2. Two blocks of mass M1 equal to 20 kg, M2 equal to 12 kg are connected by a metal rod of mass 8 kg. The system is pulled vertically up by applying a force of 480 Newton. As shown, the tension at the midpoint of the rod is equal to. So in the figure, we may see only two masses, but actually the rod is having a mass of 8 kg. So we'll construct a single unit like this, which is having a total mass of, let that be M1, the lower mass is M2, and the mass is M3 like this. And the total weight acting downwards is equal to total mass, that is 12 plus 20, 32 plus 8. 8 kg is for the rod at the, like this. So it will be 40 G is the total weight acting downward. The force which is acting upward is equal to 480 Newton. And the entire system is moving upward with an acceleration of a, let that be m into a. So the equation will be equal to 480 minus the weight, that is 400. 40g is 400, that is equal to 40 into acceleration. So that is 80 is equal to 40a, a equal to 2 meters per second square. So this is the acceleration for the entire system. Now we need to find out what is the tension at the middle point, like this. You need to find out what is the tension at the middle point. So we'll construct two masses. Let that be mass of the rod is M3. We'll take it as M3, and the lower mass, which is equal to M2, which is attached like this. I have constructed a rod as the mass M3, and the entire system is having a tension in the upward direction. This system, we need to find out what is the tension at this point, right? So the mass below that we need to consider. The mass below that is equal to M3 is 4 kilogram, because we are taking only at the middle point. Total mass is 8 kilogram at the midpoint, and the point below is having only 4 kilogram. So it is 4 kilogram. The mass M2 is equal to 12 kilogram. So 16 kilogram is the weight acting downward. 16 G is the weight acting downward. Tension is acting upward. Entire system is moving upwards. So 16A is acting upwards. So T minus 16G is equal to 16A. T equal to 160 plus 16 into 2, 32. So 160 plus 32, that is equal to 192 Newton. Answer is 192 Newton. Is it clear? Now question number 3. The two blocks M is equal to 10 kg and M equal to 50 kg are free to move as shown in the figure. The coefficient of static friction between the blocks is 0.5 and there is no friction between M and the ground. A minimum horizontal force F is applied to hold M against M, capital M, so that capital M, that is equal to. So we need to find out what is the minimum force required to hold this mass stationary against the wall of capital M. So we have two masses like this, capital M, and we have a mass small m like this. Small m, we'll take like this. And due to this, we are applying a force on the small m like this. F is the force applied on small m. And the normal reaction given by capital M on small m, let that be N. The entire system is moving forward with an acceleration of A. So what is that acceleration? A equal to total applied force divided by total mass. Applied force divided by total mass is 10 plus 50, 60. This is the acceleration for the system. Now we have a shortcut method to find what is the force in between any two masses when we have an applied force like this. So the force between any two mass is equal to applied force into mass in front divided by total mass, correct? So by using all these equations, using the equation of acceleration also, we'll find out like this. So N equal F into applied force into mass in front divided by total mass. Applied force into mass in front, that is 50, divided by total mass is 60. So the normal reaction will turn to be 5 by 6 of F. 5 by 6 times of F. Is it clear? Now this normal reaction is required to hold this mass on the surface of vertical surface of the capital M. So M into G must be equivalent to the frictional force acting upwards. So frictional force FF is equal to small m into G. So that is mu into 5F by 6 is equal to M is 10 into G is again 10. So mu is 1 by 2, 0.5, 1 by 2 into 5 by 6 into F is equal to 100. So we'll be getting F is equal to 240 Newton, right? Equal to 240 Newton. Is it clear? So here we will be getting 5 into 20, 40 into 60, we will be getting 240 Newton. So this is the case here. Since the system is moving, we need to consider the normal reaction to be like this. If it was not moving, the normal reaction will be equivalent to the applied force. Since the system will be moving, why the system is moving? Because there is no friction on the surface. There is no friction on the surface, so the entire system will be moving even with a very, very small horizontal applied force. So that is why we need to consider the normal reaction by this equation. Otherwise, it was very simple. Normal reaction will be equal to the applied force. Now, question number 4. 500 joule is spent in increasing the speed of flywheel from 60 rotations per minute to 360 rotations per minute. The moment of inertia of the wheel is equal to. So we are spending 500 joule to increase the speed from 60 to 360 rotations per minute. So the work done is equal to change in kinetic energy. Since it is rotating, we have rotational kinetic energy as half I omega square. So final kinetic energy is half I omega 2 square minus half I omega 1 square. This is the work done which is defined, which is given as 500 joule. So what is omega 1? Omega 1 is 2 pi into frequency. 2 pi into frequency. What is frequency? Frequency is 60 rotations per minute initially. So 60 by 60 rotation per second. So 2 pi rotations per second is omega 1. So what is omega 2? 2 pi into frequency, 2 pi into 360 by 60, that is equal to 12 pi radian per second is for omega 2. Now substituting in the equation of W is 500 joule, which is equal to half into I into omega 2 square, 12 pi the whole square minus omega 1 square, 2 pi square. So we'll be getting I is equal to 0.72 kilogram meter square. So this is the answer, 0.72 kilogram meter square. Is it clear? Question stem for question numbers 5 and 6. Question stem We'll read the question stem first. A ball moving with a velocity of 20 meters per second in positive x direction collides with a heavy wall moving in front of it in the same direction with a constant speed of 10 meters per second. The coefficient of restitution of the collision is 0.8. So it is an inelastic collision. The modulus value of relative velocity of the ball with respect to the wall after collision will be equal to, this is the first stem. So we have a ball which can be considered to be a mass m1 moving with a velocity of 20 meters per second and is colliding with a heavy wall that is m2, which is moving with a velocity of 10 meters per second. 10 meters per second. The coefficient of restitution of the collision is 0.8. The coefficient of restitution, so we have it in elastic collision, 0.8 is the coefficient of restitution. So the first system is the modulus value of relative velocity of the ball with respect to the wall after collision is. So we have the equation of restitution, coefficient of restitution is relative velocity of separation divided by relative velocity of approach. This is the equation for coefficient of restitution. Relative velocity of separation divided by relative velocity of approach, that is u1 minus u2. So what is the relative velocity of separation, that is after collision? E into u1 minus u2. u1 is 20, u2 is 10. So we'll be getting E into 10. What is E value? 0.8 into 10. So the answer is 8 meter per second is the coefficient of is the relative velocity after collision. So this is the equation to be remembered. E equal to relative velocity of separation by relative velocity of approach. Now next stem for this. The actual velocity of the ball after collision is, since it's an inelastic collision, the velocity of collision after for the first body after collision is, that is m1 minus em2 divided by m1 plus m2 into u1 plus 2m2. Sorry, it is not 2m2. m2 into 1 plus e divided by m1 plus m2 into u2. So this is the equation to calculate the velocity after collision for an inelastic collision. So m1 is smaller, given that m2 is m1 is much smaller than m2. So we'll be getting v1 is equal to minus em2 divided by m2 into u1 plus m2. It is m2 into 1 plus e divided by m2 into u2. Now you can cancel this m2 from this two equations. So v1 is equal to minus 0.8 into u1 value is 10, so 20. u1 is 20 plus 1 plus e, 1 plus 0.8 into what is u2? u2 is 10, right? So we'll be getting minus 1.6 minus 16. It's not 1.6. So minus 16 plus 18. So answer is plus 2 meter per second. So the body will be moving in the positive direction with a velocity of 2 meters per second. Is it clear? Question number 7. A thin uniform disc starts rolling down from the top of an inclined plane of angle of inclination 37 degree with the horizontal and length 2 meter. Mass of the disc is 2 kg and its radius is 0.1 meter. If mu of the incline is 3 by 16 at the bottom of the incline, its translation velocity will be equal to. So we can say that the inclined plane is having a length of 2 meter. It is having a length of 2 meter. Disc is rolling from that and it is rolling down. So you're supposed to find out what is the velocity at the bottom, like this. So at this point, it is the total energy is m into g into h, and it is having a friction. So friction will be doing a work against the motion of the body. So the work done by the friction is equal to ff into s. Since it is rolling, it is in the downward direction. The displacement is in the downward direction, so it will be ff into cos theta. We'll take it as ff into s. So that is loss of energy, right? So it has a mechanical energy of mgh. It has a total kinetic energy at the bottom is equal to half mv square into 1 plus k square by r square. And this value mgh is not equivalent to half mv square into 1 plus k square by r square, because some amount of energy has been lost due to friction. So mgh is the total energy. Then the mgh is the total energy which is subtracted from the work done due to friction, which will be equal to half mv square into 1 plus k square by r square. 1 plus k square by r square. So mgh into mgh minus mu k into mg cos theta. You know why it is? Because mu k into normal reaction n, and this is mg, and this will be mg cos theta. So normal reaction is equal to mg cos theta. So mu k mg cos theta into displacement is equal to 1 by 2 mv square into for a cylinder uniform disk. So k square by r square is equal to 1 by 2, right? Mk square is equal to mr square by 2, so it is 1 by 2. On simplifying this, we'll be getting velocity v is equal to, simplify this, substitute all the values, and here it is given as instead of h we need to substitute in terms of L. So g into L sin theta, this is h, g into L sin theta minus mu k g into cos theta into s equal to half into v square into 3 by 2, right? Simplify that. Sin theta is equal to sin 37. Sin 37 is 3 by 5. We know that. Cos 37 is 4 by 5. Substitute for the values and simplify that. You will be getting v is equal to root of 18 meter per second. The option is given as 18 meter per second square. So 18 meter per second. Is it clear? That is the answer is option B. Now second part of the question. Loss of translational kinetic energy due to friction. So what is the work done by the friction? Work done by the friction is Ff into S. Ff is equal to mu k into mg cos theta into displacement. So that is mu k is mu k is 3 by 16. 3 by 16 into mg. What is the value for m is? Value for m given it is 2 kilogram. And the displacement is 2 meter. So 2 into 10 into cos 37 is 4 by 5 into 2 meter. So simplifying it, we'll be getting this is 4, 2, 5, 5 is getting cancelled. The answer is 6 joule. So the work done by the friction, loss of translation kinetic energy due to friction will be 6 joule. So this is subtracted from the total energy mgh, right? Okay. Next question. Question number 9. A particle is acted upon by a force of constant magnitude which is always perpendicular to the velocity of the particle. The motion of the particle takes place in a plane. It follows that when we give a constant force to a particle, suppose I'm having a particle like this, we are giving a constant force to the particle which is always perpendicular to the velocity. So if this is the velocity and this is the force, the particle will be experiencing a centripetal force. So it will be moving in a circular path in which the velocity is continuously changing its direction. So velocity is not constant, but the total kinetic energy will remain constant. So there are two answers for this because section 3 is a section for multiple correct answers. So answer is option C. Its kinetic energy remains constant and it moves in a circular path. Is it clear? Question number 10. A wheel rotating with an initial angular velocity omega about a fixed vertical axis is brought under constant angular deceleration alpha at time t equal to 0 and comes to rest in 8 seconds. So initial angular velocity will take it as omega naught, which is given it as omega, we'll take it as omega naught, and angular deceleration it is given by alpha, and in t equal to 8 seconds it is coming to rest. So that is omega dash, final angular velocity will be equal to 0. The first 2 seconds it makes 112 revolutions. So first we will write an equation for this. Omega dash minus omega naught equal to alpha into t. Omega dash minus omega naught is equal to alpha into t. So that is equation number 1. Then it is given in the question that it is coming in first 2 seconds it makes 112 revolutions. So what is delta theta? 112 into 2 pi, right? So displacement delta theta equal to average angular velocity into time taken for that. Delta theta is 112 into 2 pi. Average angular velocity is omega naught plus omega 2, that for 2 seconds divided by 2 into how many seconds? It is for 2 seconds, correct? So we'll be getting omega naught plus omega 2 is equal to 2 is getting cancelled, is equal to 224 pi. Therefore omega naught is equal to omega 2 is equal to 224 pi minus omega naught. Is it clear? So this is the value for omega, this is value for omega 2. Now keep it like this. Now we will consider the remaining 6 seconds. In the first 2 seconds it is having 112 revolutions. So in first you consider like this. So it was having angular velocity, initial angular velocity omega naught. In 2 seconds it is omega 2, and finally in 8 seconds it is equal to 0 now. This is 8 seconds. Complete time is 8 seconds. So complete the time for making it 0 is 8 seconds. This first 2 seconds, this is 6 seconds. Now the second section will take like this: omega dash minus omega 2 equal to alpha into t. Alpha into t. Omega dash, it is equal to 0. Omega 2, it is equal to, we have already discussed, that is 224 pi minus omega naught equal to alpha into 6. Correct? This is what is omega alpha. So you can take alpha is equal to 224 and plus omega naught is equal to 6 alpha, or take omega naught is equal to 6 alpha plus 224 pi. This is equation number 3. So you got what is the value for omega naught from this. Now substitute 3 in 1. Substituting 3 in 1. That is omega dash minus omega naught. That is 6 alpha. Omega, what is the value for omega dash? Final angular velocity, it is equal to 0 now. So 0 minus 6 alpha plus 224 pi is equal to alpha into 8. That is 224 pi is equal to 14 alpha. Minus 224 pi is equal to 14 alpha, or alpha is equal to minus 224 pi divided by 14. It is equal to 16 pi radian per second square. So the angular acceleration is equal to 16 pi radian per second square. Is it clear? So the hard type question. So you have to split the question into 2 parts. First one for the complete section, second part for this section, and third part will again take omega naught to omega dash. Simplifying, we'll be getting 16 pi radian per second square. Okay. So in this question there is a second correct answer. First correct answer we have alpha equal to 16 pi already we got. The second correct answer we'll check what is that. The number of revolutions per second initially is 64. So initial angular velocity we can substitute in this equation. This omega dash minus omega dash is equal to 0 minus omega is equal to alpha value. We know that it is 16 pi minus 16 pi into t. What is t? T is for 8 seconds. So 2 pi into frequency is equal to 16 pi into 8. So we have, this is 4, pi is getting cancelled. So frequency is equal to 64. Frequency is equal to 64 hertz. Is it clear? So frequency is 64 hertz. So the number of revolutions per second initially it is equal to 64 hertz. What is the total number of revolutions it makes before coming to rest? So before coming to rest, you can say that there is a total number of revolutions. For finding the total number of revolutions, we can consider the equation as delta theta is equal to final angular velocity plus initial angular velocity divided by 2 into t is the total time taken, right? Delta theta is equal to omega naught plus omega dash is 0, omega naught is 6 alpha plus 224 pi. You can alpha, you can substitute 16 pi, so it is 320 pi by 2 in the total time taken is 8 seconds. So delta theta is equal to 160 pi into 8. 160 pi into 8, correct? So what is delta theta? 2 pi into number of revolutions, number of rotations, that is 160 pi into 8. So is 2 pi is getting cancelled, it is 4. So n is equal to 640 revolutions, right? So total number of revolutions has taken place is 640. So the options which are correct is option A and option B. Is it clear? Okay. Question number 11, section 4. In each of the following questions, match column 1 and column 2 and select the correct match out of the four given choices. Match the following column 1. You can see that Newton's first law. It is explaining about inertia. It is known as law of inertia, so it's stable equilibrium of the body. Newton's second law is also known as law of forces. Newton's third law, it explains about the flying nature of the bird, and Newton's law of conservation of linear momentum is explaining about the propulsion of a rocket. So this theory is a theory based question. So answer is option A. Clear? Question number 12. A disk of radius r rolls on a rough surface with a constant angular velocity omega. V is the linear speed of the center of mass of the disk. Then the speed of the points in the column is. So you can see we have the pure rolling case in this. So the center of mass will have the velocity v itself. it is rotating with an angular velocity omega, and here the point of contact, the velocity in the backward direction, since it is rotating like this, the tangential velocity will be equivalent to the velocity in the forward direction. So net velocity at the point A will be equal to 0. So they are the opposite direction. At the point C, you can see that at the point C the velocity is v, and it is also, the tangential velocity is also in the direction of v. So it will have translation velocity and velocity due to rotational motion. So the velocity at the point C will be equal to 2v, or it is equal to 2r omega. 2r omega. Now velocity at the point O, it is equal to v itself. Now the remaining velocity is at the point B. At the point B, you can see that it makes an angle of 60 degree. 60 degree. So this is the, but due to rotation, the tangential velocity will be like this, v, and the velocity due to the center of mass will be in this direction, v. So the angle between them will be 120. So the resultant velocity at that point will be v itself. So vb is equal to vb. vb is equal to v. So these are the answers you can see. So it is va, it is equal to 0. 1 is s. vb is equal to vb. 2 is q. And vc, that is velocity at the point C, it is equal to 2v. So it is 2r omega. Velocity at the point O, that is it is equal to v itself. So it is q. So answer is option A. 1s, 2q, 3p, 4q. Clear? Okay. Next one. 4-point mass of values are shown, are connected by a thin, massless rod as shown in the figure. The radius of the gyration of the system about the point, about AB is root n, where n is. So radius of gyration, we have the equation m into k square equal to total mass into k square. What is the total mass of the system? M plus 2m, 3m plus 3m, 6m plus 4m, that is 10m. 10m into k square equal to m into 0, 2m into a square plus 3m into 2a square plus 4m into 3a square. 4m into 3a square. So 10m into k square equal to, you will be getting 2ma square plus 4 3 12, 12ma square plus 9 4 36, 36ma square. So what will be this? 14ma square, that is 50ma square equal to 10mk square. M is getting cancelled. This is known, that is you will be getting a square equal to k square equal to k equal to root 5a. So n is equal to 5. N is equal to 5. Answer is option. Answer is 5. It's integer based questions. Answer is 5. Clear? Okay. Next one. Question number 14. A 150 kilogram mass is at rest on a floor with mu equal to 0.75. The minimum value of F is required to move the box is 100 n. The value of n is equal to. So we know that the minimum force required to move any mass on a horizontal rough surface is equal to mg sin theta, right? So here it is given as mu equal to 0.75. That is tan theta is equal to mu. We know that tan theta is equal to 0.75, 3 by 4. So sin theta will be equal to 3 by 5, right? We know that if tan theta is equal to 3 by 4, it is theta is equal to 37 degrees. So sin theta is equal to 3 by 5. Substituting in the equation, so F minima is equal to mg, it is 150 into 100 into 10 into 3 by 5. So we'll be getting 900 Newton. So answer is the integer value, that n is equal to 9. So answer is 9. Okay. Next. A body of mass 4 kg is projected at 20 meter per second. So question number 15. A body of mass 4 kg is projected at 20 meter per second at an angle of 57 degree to the horizontal. So it is projected at an angle of 57 degree with a velocity of 20 meter per second. Clear? Power of the gravitational force on the block at its highest point. So at the highest point, you can see that the force is like this, and the velocity will be like this, right? So both are mutually perpendicular. So power equal to Fv cos 9d. So it is equal to 0. Answer is 0. Clear? Question number 16. Section 6. It is paragraph type. A cylinder of mass m and radius r free to rotate about its axis is pulled down on a rough inclined plane as shown in the figure by applying force F equal to mg as shown. The cylinder rolls without slipping. The acceleration of the cylinder is given by. So you can see that this is the inclined plane. So we are applying a force, pulling it with a force F. Due to gravitational gravity, it is having a force mg sin theta in the downward direction. The frictional force is acting in the upward direction. Right? That is helping it to rotate. Then what is the acceleration for the system? So what is the acceleration? That is F plus mg sin theta equal to, so we have the equation for acceleration down the plane, A equal to g sin theta by 1 plus k square by r square. I am taking the shortcut equation, g sin theta by 1 plus k square by r square, but along with this g sin theta plus 1 plus k square by r square, we have g also, because it is we are pulling a force, we are pulling it with a force mg. Therefore, m is cancelled in both the sides. So when you take the acceleration, it is equal to g itself. So A equal to g sin theta 10 into sin 53. It is going to 53 degree. The sin 53 is 4 by 5 plus 10 divided by 1 plus k square by r square. What is k square by r square? K square by r square is 1 by 2 for a cylinder, right? It is a disc. It can be considered to be a disc. So it is 1 by 2. So simplifying this, we will be getting A equal to 8 plus 10, 18 divided by 3 by 2. So 6 3s are 18, 6 2s are 12. So answer is 12 meter per second square. Option C. Clear. So for pure rolling, the friction force developed will be equal to, the last question we have discussed, when it is rolling downward, it is having a force F plus mg sin theta in the downward direction. The frictional force is acting in the upward direction. So net force, since it is moving downward, we can take it as m into a in the downward direction. So F plus mg sin theta minus frictional force will be equal to m into a, right? So we'll be getting F is mg plus mg sin theta minus m into a, it is equal to frictional force. So simplify this, we'll get the answer as 6m. Sin theta, it is equal to sin 53. Sin 53 is 3 by 5. 4 by 5. Substitute in that, we'll be getting the answer as 6m. Answer is option C. Question number 18. An elevator has a mass of 1000 kg and carries 800 kg load. So it is 1000 kg and carries 800 kg load. A constant frictional force of 4000 Newton. So when it is moving upward, the frictional force will be acting in the downward direction, correct? So net force required is F net, like this. The net force required to move it upward, F net is equal to 1800 G plus 4000. So we'll be getting 1800 G is 18,000 plus 4000. It is equal to 22,000 Newton is the force required by the motor. So the power required is equal to this force into velocity. So 22,000 into velocity is 366,000 watt is the required power. So in HP, horsepower, we know that 1 HP is equal to 746 watt. Therefore 66,000 watt can be converted to HP as 66,000 divided by 746, that is equal to 88 HP. The answer is option C. Is it clear? Next, the power required at the instant the velocity is 3 meter per second, with the elevator has an upward acceleration of 1 meter per second square is about. So when we consider the elevator moving upward with an acceleration of, it is moving upward with an acceleration of 1 meter per second square, 1 meter per second square. A downward weight, it is equal to 1800 into G, that is 18,000 Newton. And the upward, the tension in the cable, it is T. Then it has a frictional force acting in the downward direction, FF. So we need to calculate what is the power required at the instant the velocity 3 meter per second if the elevator is moving upward with an acceleration. So they are given an acceleration of 1 meter per second square. So T minus 18,000 plus 4,000, that is a frictional force, that is equal to 1800 into A. Clear that 1800 into A the value, it is equal to 1 meter per second square. But T is equal to 18,000 plus 4,000 plus 1800. Here we will be calculating the tension value. T is equal to 18,000 plus 5,800 equal to 23800 Newton. Alright, 23800 Newton. Now we calculate what is the power required. P is equal to F into V. That is, F is tension T, 23800 into velocity is 3 meter per second. So it is 71 into 10 to the power 3, that is 71 kilowatt. So answer is option A, 71 kilowatt. Is it clear? So hope you understood the discussion. Thank you.